it's time for reading again, and as you know, we are working on being good readers by practicing the different characteristics that good readers have and by exploring the different genres. So today, for your good reader characteristics, you're going to listen carefully. You're going to learn new words. You might even make a connection to your life or share some ideas and feelings, okay? And the genres we've been taking a look at are fiction, nonfiction, and poetry. So I'm going to show you some of the books we're going to look at today, and I want you to see if you can pick out what genre they are, okay? So, this one's called Sun Up, Sundown by Gail Gibbons. The Moon Seems to Change. What Makes Night and Day? And Sun, 1 in a Billion. If those books are going to be teaching you information about the sun and the moon and space, are they fiction, nonfiction, or poetry? If you said nonfiction, you are right. Nonfiction is not fake. It's real and true, and it gives you information. The word that we were focusing on yesterday was facts. Nonfiction has facts, okay? Facts are those little pieces of information that you learn from books. And one way that authors give you these facts is in their illustrations or their photographs. So yes, the words are going to be really important, but sometimes you can't read all the words or remember all the words. So using the visuals, things that you see, help you remember things from the text. So I told you yesterday when we were studying motion that was going to be one of our science topics this year. That same thing is true for these books. We are going to be learning all about outer space and the sun and the moon in our science unit this year. So it might not be the first one that we do, but we will get to it at some point, and that's probably going to be my favorite science thing that we do. I'll show you a different science thing tomorrow and a different science thing the next day, but it is kind of exciting to read nonfiction books because you get to learn all of this new information. So what I want to read to you today looks like it could be fiction because somebody drew these pictures. If the title says sun, this isn't what I see when I look up at the sun. But it would be really hard to look up at the sun because it's so bright. And it'd be really hard to take a good picture of the sun because it's so big and far away and bright. So sometimes people do have to draw things in nonfiction books. You can't always take a picture of it. So that's why I wanted to read Sun today, because it's still going to give us true information. It's still going to try and teach us something about the sun. But the visuals, things that you see, are going to look a little bit different. Okay? So as we're going through, think about a fact that you can remember, something that you learned about the sun from this book, because it's teaching you something in nonfiction. Ready? Once upon a time, about 4.6 billion years ago, a magnificent and important star was born. And that magnificent and important star was me, your sun, with a capital S. So we use a capital S for this word sun because it's the name of this guy here. So even though it sounds like it's made up because the sun is telling the story and we know the sun can't really talk, we're still going to consider it nonfiction because all the information in this book is going to be true. So it's called literary nonfiction because it's still written like a story, but nonfiction gives you true facts information. Yes, I am a star. Star is a massive and luminous ball of gas and full of energy. See how he's looking up that word in the dictionary to find out what it means? It says, 2, an outstandingly talented and popular performer. I fit both definitions. So again, this is the silly page, but it is true information because it is a massive and luminous ball of gas that's full of energy. Maybe that can describe you too. Are you a luminous ball of gas that is full of energy? Look at this beautiful page. The Milky Way galaxy has over 1 billion stars. That makes me 1 in a billion, or 1 in 100 billion. So again, this visual can help you see just how many stars are out there similar to the sun. And then here's our sun. So if we know how big the sun is and we see how small this looks compared to all the other ones, think about how small we are as people on a planet that goes around that little ball of gas there. That's bananas. I'm not the biggest. So what? I'm not the brightest. Who cares? I'm also not the oldest. Whatever. But I am the most important, at least to you earthlings. And that's super true, because think of all the things that the sun does for us. Keeps us warm, it gives us day and night, it helps us grow food that gives us energy. So it is pretty important, even though it's not the biggest sun or the brightest sun or the oldest sun out of all of these stars in the galaxy. It says, can you hang out for 8 minutes? That's how long it takes my light to reach the earth. Yep, I give you heat and light. You're welcome. I'm so important that earthlings should name a special day in my honor. We call it Sunday. Oh, wait, that's already true. Sunday. And it happens every week. But pretty cool that it takes 8 minutes, because the sun is actually so far away, for light to leave the sun and travel all the way through the sky down to Earth. I'm famous for my heat and light, but I also hold our entire solar system together. Scientists call it gravity. What can I say? The planets are attracted to me. And I showed you a book on gravity yesterday in our Force and Motion. We didn't read it, but it'll be here in case you want it. I think this is a pretty cool page. This might be the one that I take a picture of. Take a look at all the information that the author is giving to you just by drawing this picture. Okay, I'm going to read all those words, but what I really want you to notice is the way that these circles help you understand what's happening. Okay? It says, and because I'm the center of our solar system, life revolves around me. Literally. Look, they all go in the same direction. Okay, so here's the sun in the center of our solar system. And then each of these little rings is a path that one of our planets follow, because all the planets in our solar system go around the sun. So from this page, you might learn that the sun is the center of the solar system. You might learn that the planets all go in the same direction around the sun. You might learn that there's 1, 2, 3, 4, 5, 6, 7, 8 planets. You might even learn their names and some little facts about them. There's lots to learn just from this picture. Okay, so I'll start with the closest to the sun. It says Mercury. It takes 88 Earth days for Mercury to go around the sun. So that makes a mercurial year 88 days long. A Venusian year is 225 Earth days, because it takes 225 days for Venus to go around the sun. Earth is 365 days, so our year is 365 days long, except on the leap year, which was last year, and we talked a little bit about that in kindergarten. So that's what we consider an average year with our 4 seasons from January all the way through December, 365 days. But as you work your way out, the numbers are going to get bigger, because it's going to take longer to travel around the sun. So we've got Mercury, Venus, Earth, Mars, and a Martian year is 687 days. Okay? Then we've got Jupiter, which is 4,333 days to go around the sun. Saturn takes 10,756 Earth days to go around the sun. Uranus takes 30,687 Earth days to go around the sun. So I would like to divide like Earth years into Uranus years and see if like somebody would be able to like live all the way for around one trip, because 30,687 seems like a lot of time for it to be just 1 year on that planet and go all the way around. But then we get to Neptune out here, and he takes 60,000, so almost double what this one took. 60,190 Earth days to make one trip all the way around the sun. That is a really long year. Those other stars are far, far away from Earth, which makes them look teeny tiny and not so important. But I'm close. I'm a mere 93 million miles from Earth. To an Earthling, I look like this. But to Neptunians, I'm 2,795 million miles away, and I look more like this. If there were Neptunians, there are no known life forms on Neptune. So again, these visuals really help you understand what the author is trying to teach you, right? How different the sun looks from where we stand on our planet, because it's much closer, versus what it looks like if you were to stand on the furthest planet away right here. Technically, I'm a yellow dwarf star, but I'm still a big, big deal. So here he is holding up a pretend license. It says name, sun, type, dwarf star, date of birth, long ago in the G2 Milky Way galaxy. And it's making a joke. It says he's a plasma donor. If I were the size of a basketball, Earth would be smaller than a grain of sand. So again, think of that visual. If you have a basketball, go get it out and think, if this is the size of the sun, then Earth is only about that big, and you are just one teeny tiny person on that grain of sand compared to the sun that's a 1 in 100 billion of those stars. That is bananas. It says you could fit about 1 million Earths inside of me. 1 million. I don't even know if we could count that high. But you can't fill me with Earths because I'm hot stuff. Let's compare. A hot summer day is 90 degrees. A pizza oven might reach 700 degrees. The orange and yellow flames in a campfire reach about 2,000 degrees. But me, about 10,000 on the surface. I can melt diamonds. Me at my center, 27 million. So if you thought a campfire was hot at 2,000, imagine 10,000 or 27 million degrees. That's hot. Ancient Earthlings thought I circled the Earth. Can you imagine me revolving around the Earth? And some might think that I sit in the sky all day and all night. But I got moves, baby, because I'm spinning. And because I'm not solid, my middle moves faster than my top and bottom. Okay, so don't try this at home. Take a look at him going round and round. It says about 25 Earth days to rotate and about 36 Earth days to rotate. So his middle moves faster than his top and bottom. That seems kind of crazy. I'm not only important, I'm generous and I'm good looking. I make sunrises, sunsets, the northern lights, and the southern lights. And I think those are some of the things that I would like to go see. I think that would be beautiful. Sunrises and sunsets are beautiful, but I would like to see some of these special lights. It says, sit back and enjoy the show. I hope that you're learning some new information about the sun because you see it every day, but you probably didn't think about all these things that there are to know about it. And that's what's so cool about nonfiction is how much reading these books can teach you. Sometimes I like to be mysterious and sneak away for a few minutes. Solar eclipse. But don't worry, I'm just hiding behind the moon. While I'm astronomically bigger than the moon, 400 times wider, the moon is astronomically closer, almost 400 times closer. So you know how something looks bigger when it's like really close to your face, and then the further that you move it away, it looks a little smaller, and if like you were standing way, way back, it would be like teeny tiny, sometimes to the point where you can't even almost see it anymore. The same thing is true. The moon is smaller, but because it's closer to us, we can see it a whole lot better. The sun is bigger, but it's further away, so it looks smaller. Tricky. My neighbor stars have fancy names. Meet Proxima Centauri, Alpha Centauri A, and Alpha Centauri B. Me, I just need 3 letters. Give me an S. Give me a U. Give me an N. What does that spell? S-A-N. Sun. Sun, sun. He's our star, light and heat from afar. Please note, that's a capital S because I am important. Not to hog the spotlight, but I've still got it. I'm the same hot, bright star that I've always been. And think about that. The sun has been around longer than any of us, than any of the newspapers or the things that you see from long, long ago. The sun was even there when the dinosaurs were there, and even longer. Almost done. It says, so grab your shades. I plan to be in the biz for another 6 billion years. You and me, we've got a bright future together. The end. And you can see all of these cool features in the back. That's something else that nonfiction books have. I showed you the table of contents in the front yesterday, but this one doesn't have a table of contents because it wasn't written in that same, heading, different pages tell different things structure. But it does have some cool things in the back there that other nonfiction books might have, like sources where they got the information from, a glossary or an index. We're going to be talking about all of those cool text features when we dive more into nonfiction. So thanks for learning about the sun with me. I'm going to go ahead and take a picture and put it on Seesaw, and hopefully it helps your brain remember some facts that you learned about the sun. See you later.